Hello, in today's video we will be looking at what an oblique asymptote is and how to solve for them. In this video you'll need to understand how to either perform long division or synthetic division. And so if you need a refresher, I will link a few videos in the description below. But an oblique asymptote is similar to a vertical or horizontal asymptote in that it's just a line. So what we've seen before is we've had a graph, and potentially you could have a vertical asymptote, or you can have a horizontal asymptote in which the function approaches these lines but never touch it. Well, an oblique asymptote is, rather than a vertical line or a horizontal line, it's a line that is a diagonal. So a oblique asymptote takes on the look of this. And so similarly to what horizontal and vertical asymptotes are, this graph will approach this line but will never touch it. You can have vertical asymptotes, you can have oblique asymptotes, and you can also have horizontal asymptotes all in the same graph. As we just noted, an oblique asymptote will be a straight line, and therefore it will take on the form of a straight line, which we know to be y equals ax plus b, where a in this case is not equal to 0. And so how do we get there? Well, if we're talking about a function that is its own line, then it's considered its own asymptote. However, if we're talking about rational functions, where you have a function and you have the polynomials g of x divided by h of x, then if g of x is 1 degree greater than the degree of h of x, then you know you're going to have an oblique asymptote. If you're unsure of if the numerator or that polynomial g of x has 1 greater degree than the denominator of h of x, then this is where you would use long division and or synthetic division to determine what that asymptote is. I also do want to note that for graphs of rational functions with increasing difficulty, so higher degrees, those functions that are more complex may approach different types of curves asymptotically. What I mean by that is if you do this long division method or the synthetic division method, you might not get a y equals ax plus b line. You might actually get some other curve or some other function, and that answer that you get will be an asymptote to that function. It might not just be an oblique asymptote. We will not be getting into those advanced problems in today's video, but I did want to point that out, that the same method does work even for higher degree polynomials. Okay, let's look at a few examples. Looking at our first problem, we have the function f of x equals x squared minus x minus 6, and we're dividing that by x plus 1. And the question asks us to identify if there are any oblique asymptotes, and if they are, solve for the oblique asymptote. So with the first part of this question, we can see we're given in the problem the numerator, which is x squared minus x minus 6, which is a degree of 2. And then in the denominator, we are given the x plus 1, which has a degree of 1. By our rule, we do know that if the numerator has 1 higher degree than the denominator, then the function will have an oblique asymptote. So for part A, we can say, yes, it does have an oblique asymptote. Now what we need to do is solve for an oblique asymptote. And how to do that is either by long division and or by synthetic division. Again, I will leave videos in the description detailing exactly step by step how to go through both long and synthetic division. For this problem, we do see that we have this term here, which is representative of that c minus 1 term, which is necessary for synthetic division. So because synthetic division is more simplistic in approach, we are going to utilize the c minus 1 and synthetic division versus long division. So with that, out in front of our table, we're going to put that -1 because that c minus 1 is representative of that x plus 1, which means that that needs to be a -1. And then we bring down our polynomial from the numerator, and that is 1, -1, and -6. Next, we bring down that first term, which is 1, multiply 1 by -1, which gives us -1. -1 plus -1 is going to be a -2. Then we do -1 times -2, which is 2. We put that under the 6, and we add those together to give us a -4. Now, what we do is we can rewrite the polynomial, and that is we just need to write this with one less degree than our original polynomial. So in our original polynomial, we had that x squared, and so in this polynomial, we are going to be left with x, and then -2, and then we are left with that -4, which means we still need to divide that by the x plus 1. However, we see that we have this x minus 2, which is representative of our line of an oblique asymptote, which is following that y equals ax plus b. We can use this part of the equation and rewrite y equals x minus 2, and we know that this is our oblique asymptote. So then we can say that the function f of x, x squared minus x minus 6 divided by x plus 1 has an oblique asymptote which is equal to y equals x minus 2. Which means this rational function will approach this line but will actually never touch this line. Again, we use synthetic division. However, if you're more comfortable, you're able to use long division and come up with the exact same answer. Okay, let's look at another problem. In our next example, we have 8 minus x cubed divided by 2x squared, and the question asks us to find if there are any oblique asymptotes, and then if there are, determine what that oblique asymptote is. We know from our rule that if the numerator is 1 degree larger than the degree in the denominator, we know that we have an oblique asymptote. So then all we'll need to do is synthetic or long division to identify then what that oblique asymptote is. So with synthetic division, we do need that 1 minus c. Because we don't have that 1 minus c term, we're just going to do long division, which is fairly simple in this problem. So if we rewrite this to show all of our missing terms, we have that negative x cubed plus 0x squared plus x plus 8. And we're going to divide that by 2x squared. How we get this first term is a negative 1/2 x. When we multiply those together, that's going to give us a negative x cubed, which is exactly what we want. And then we add this together, that crosses that out, and that gives us 0, 0. That's also supposed to be a 0x, so then that gives us 0, and that just leaves us with 8 here. And then we know that 2x squared cannot go into 8, so that means this is left to 1 divided by 2x plus 8 divided by 2x squared. We take this portion of our answer, and that corresponds to our y equals ax plus b and is our oblique asymptote. So we say that y equals negative 1/2 x is our oblique asymptote. And we're saying that for the rational function f of x equals x minus x cubed divided by 2x squared, there will be an oblique asymptote, which means this function will approach negative 1/2 x, but will never cross that line. And there you go. Now you can identify if a function has an oblique asymptote and how to solve for those oblique asymptotes. You can either use long division or you can use synthetic division, and you will come up with the exact same answer. If you have any questions or comments, please leave them below. If you learned something, please like and subscribe, and we'll see you next time.